So what we're looking at here is this. We're looking at the theorems about zeros of polynomial functions. What does that mean? When we say theorems about zeros of what are zeros? What are zeros? X, yes, you're almost there. X what? The x-intercept. It's also called a solution. The zeros come from the factors. So all of these words are synonymous. They pretty much find the same thing. Up until now, we've talked about linear equations. We've talked about quadratic equations. We also looked at cubic functions. And the only method we know so far of solving cubic equations with the power 3, we can only solve it if it has 4 terms. Then we can use grouping. If we can't do that, then we have now we're done with our arsenal of things. That's what this chapter talks about. At the end of this section here, you'll be able to take any polynomial, any size, any degree, and solve it. That's all based on the coefficients. The coefficients are the numbers in front of the variables. Good morning. So in certain cases, we're only restricted to those kind of coefficients. Integers are counting numbers, 5, 3, 8, 11. Real numbers are anything between negative infinity and positive infinity, right, like square root of 2, pi, all this stuff. Rational numbers are fractions, which are subsets of real numbers. These are all polynomials. There's a fourth one that we also have to be considerate about. Because if you notice, okay, we have square root, we have pi, we have fractions. The only other one that we have to also consider are what are called complex. What is a complex number? What does a complex number look like? The reason they call it a complex number is because it has both a real number and an imaginary. That's a complex number. So the fourth possible condition that we can look at are complex numbers. Because we're going to see in this section that there's a important and unique concept restriction on complex numbers that they have to happen in pairs. If you have one complex number, there always has to be a second one. Why? We did this when we talked about complex numbers in chapter 2. In reality, you can't really end your answers if you have an I in the equation. You have to get, if you have power, you have to get rid of that power on I's. If you have a complex number, we cannot, in the rules of math, we're not supposed to be, we're not supposed to have a final answer with imaginary numbers in there. So how do we get rid of the imaginary number? What's that called? Only thing I did was change the sign in the middle. This number here, so if this is a plus bi, this number here, a minus bi, is called the complex conjugate. The complex conjugate, I'll show you what it does. So if we multiply these two together, what do we get? A times a is a squared. A positive times negative is negative. A times bi, that's that one. Then we have positive times positive. A times bi. Positive times negative is negative. B times b is b squared. I times I is I squared. These two cancel each other out. They're opposites of each other. So we have a squared minus b squared, I squared. Well, what does I squared do? I squared is the same thing as -1. It changes the sign of its coefficient. So the complex conjugate gets rid of the imaginary numbers. We use that whenever we have an I on the bottom of a rational equation. We use the multiply by the complex conjugate to get rid of that imaginary number. So this is the reason whenever you have an I as an answer, it has to happen in pairs. So if one of your answers is 2i, there automatically has to be a negative 2i answer. They have to happen. What these are called conjugate pairs. So whenever you solve your equations, your intercepts, whenever you have one imaginary number, there has to be the equal complex conjugate to it. So they have to happen in pairs. Now, why is that important? Let's think about it. In all of these examples I have here, what degree is it? What's the degree of all four of these examples? Three. So that means we have three possible solutions. If one of them is 2i, then the other one has to be negative 2i. So that takes care of two of the possibilities, which means we only have one other answer. It can either be a positive number or a negative number. But two of them are taken care of because if you have an imaginary answer, it has to be its complex conjugate. And that we're going to look at more of that in today. All right, so what we're looking at here is we're going to find with given zeros first. What does that mean? Finding polynomials with given zeros. Remember, zeros are our x-intercepts. So here's my example. If I ask you, find the polynomial with zeros, -2 and 3. What we're doing here, we're working backwards. I gave you the x-intercepts. They're my zeros. So what I know here is that x equals -2 and x equals 3. Those are my solutions. Since they're zeros, I have to make these equal 0. So I add 2 to both sides. I subtract 3 from both sides. So we have x plus 2 equals 0. X minus 3 equals 0. Bless you. These are my zeros. Now I combine these two. I take x plus 2, x minus 3, and they equal 0. Remember, since we have two zeros, what kind of equation we're going to have? What's our degree? Yeah, the degree is number of x-intercepts you have. So the equation is degree 2. Means it's quadratic. This is where it's coming from. Now we multiply these together. X times x is x squared minus 3x plus 2x minus 6 equals 0. Combine like terms. X squared minus x minus 6 equals 0. So my polynomial, f of x, is x squared minus x minus 6. That's the polynomial I'm looking for. Okay, how do we know that that's the true polynomial? How do we know that this polynomial has -2 and 3 as zeros? If you put them inside the function, we got -2 squared minus -2 minus 6. -2 squared is 4. Negative and negative is a positive. 4 plus 2 is 6. 6 minus 6 is 0. So if we plug them in there, it has to come out equal 0. Same with 3. 3 squared minus 3 minus 6. 3 squared is 9. 9 minus 3 is 6. 6 minus 6 is 0. So since these are zeros, if this is my correct polynomial, if I plug them in there, they have to equal 0. Just remember, this equals y. They're x-intercepts. All right, so let's look at some examples here. Example 1. It says, find the polynomial, find p of x of degree 3 having 1, 3i, and -3i as zeros. So this question is asking us, find a polynomial of degree 3, which means we have 3 possible solutions. 1, 2, 3, check. When we finish, the highest exponent we'll have is 3. Remember, the highest exponent is the degree. So how do we do this? Well, 1, 3i, and negative 3i are zeros. So we set x equal to those x-intercepts. Next step is what? A pen? I have pen, not a pencil. Yeah. So what's my next step?
Set them equal to 0.
Set them equal to 0. So in this first one, I have to subtract 1 from both sides. Subtract 3i from both sides. And then add 3i to both sides. So we have x minus 1 equals 0. X minus 3i equals 0. X plus 3i equals 0. So we first set x equal to those zeros, then make them equal 0. Then what?
Then we subtract
No.
term by both from both sides.
No.
I had the words for a second and then I lost it. Isolate x.
Not yet, because we had isolated x here originally. The third step, because the first step, we set x equal to the zeros.
Right.
Then we make these equations equal 0. Third, multiply each binomial. Set equal to 0. So we have x minus 1, x minus 3i, x plus 3i. That equals 0. Multiply together. So in this one, I do the complex ones first. I multiply those together first. So I have x minus 1. X times x is x squared. Plus 3xi minus 3xi minus 9i squared. Because 3 times 3 is 9, I times I is I squared. Combine like terms, so the middle terms cancel. We have x squared minus 9i squared. I squared, your i's can never have exponents, so that changes the sign of its coefficient. So we have x minus 1 times x squared plus 9. Now I'll multiply these two together. X times x squared is x cubed. X times 9 is 9x. Negative 1 times x squared is negative x squared. Negative 9. Rewrite it so it's decreasing powers. And that's your polynomial. Is x cubed minus x squared plus 9x minus 9. That's how you find the polynomial of that function. Do no. Let's look at another example of that one. Find the polynomial of degree 3 with zeros 2i and 3. Go ahead, do it. So what are my zeros? Or what are my x's? X equals 2i.
And then X equals 3.
What's the degree? The degree is what? Which means I have to have 3 answers, 3 x-intercepts. No. Minus 2i. Very good. All imaginaries have to have their complex conjugate.
So in other words, for example, there can't be a 2i, there can't be x equals 2i without an x equals
Negative 2i, right? Because they have to have complex conjugate of itself. Because when it says degree 3, we have to have 3 equations that deal with. Set them equal to 0. Then what? Yeah. So we have x minus 3, x minus 2i, x plus 2i, all that equals 0. Do the complex numbers first. So we have x times x is x squared plus 2xi minus 2xi minus 4i squared. By this time, again, multiply these together should not be any problem. That's why I'm not wasting any time going over it too deep. We should know how to FOIL. Combine like terms, the middle terms cancel. X squared minus 4i squared. The I squared changes the sign of the coefficient in front of it. x squared plus 4. Now we multiply those together. Again, this should be second nature to you. Hopefully you've practiced this enough. Minus 3x squared. 12 equals 0. Rearrange them in decreasing order of degrees. So it's x cubed minus 3x squared, 4x minus 12. And that's your polynomial. And you could go ahead and check it by plugging those zeros in there. Let's look at example 2. Because remember, the last section, we looked at some special type of numbers. Example 2. Find the polynomial function of degree 5 with -1 as a 0 of multiplicity 3, 4 as a 0 of multiplicity 1, and 0 as a multiplicity 1. First day of school, I told you all that math is a language. You have to know the words. What does all this stuff mean? Find the polynomial of degree 5. What does that first sentence tell us?
But there are 5x intercepts.
There are 5 answers, 5x intercepts. So the highest power we're going to have is 5. Right. So our polynomial, once we finish, will have whatever. It's going to be x to the 5th, x to the 4th, x or whatever. And there are 5 solutions. Do we have 5 solutions?
Not yet.
Yes, we do. Because -1 is a solution. That's a 0. 4 is a 0. And 0 is a 0. So we do the same thing we did in the past, is set the zeros in there. So x plus 1 is equal to 0. X minus 4 is equal to 0. And x equals 0. Multiply all these together. So we have x times x plus 1, x minus 4, in the statements, they said that -1 as a 0 of multiplicity 3. What does that mean? What does multiplicity 3 mean? We did multiplicities last time. So the -1, this one, is multiplicity 3. So that means it occurs 3 times. 4 is a 0, so this one occurs 1 time. And the 0 occurs 1 time. Those are our multiplicities. If we add the multiplicities, we get the degree, right? And here's the reason why that is. Because x to the power 1, this goes there, so x to the power 3, x to the power 1, so 1, 2, 3, 4, 5. There are 5 x's. Here's the horrible part about this question. X plus 1 times x plus 1 times x plus 1. We have to find the polynomial that matches this. So guess what we have to do?
Factor all of them.
Multiply them all together, right?
Multiply.
Yeah, that's gonna be the hard part. Not hard, it's just be long.
Yeah, labor intensive.
Very labor intensive. So it's okay. Let's do these two together and let's do these two together. So x plus 1 times x plus 1 is x squared plus x plus x plus 1. X squared minus 4x plus x minus 4. Combine like terms. So we have x squared plus 2x plus 1. X squared negative 4 plus 1 is negative 3x minus 4. Now let's multiply these two together. X squared times x squared is x to the 4th. Positive times negative is negative. X squared times negative 3x is negative 3x cubed. There's 2 there, there's 1 there. Positive times negative is negative. X squared times 4 is 4x squared. Repeat the process. That's why I don't like, when we talk about, this is distributivity. It's not FOIL. FOIL only works when we have binomials. It's just everything in this first bracket multiplies to everything in the second bracket. So we have 3 terms here, 3 terms here. When we finish 3 times 3, we should have 9 pieces. So 2x times x squared, positive 2x cubed. Positive times negative is negative. 2x times 3x is 6x squared. Positive times negative is negative. 2x times 4 is 8x. And the last one, 1. 1 times x squared is plus x squared. Positive times negative is negative. 1 times 3x is 3x. 1 times -4 is -4. Combine like terms. Start from the highest exponent. X to the 4th, there's only one of those. X cubed, we have one there, there's there. So -3 plus 2 is -1. X cubed. Now the squares. We have -4, -6, and +1. -4, -6 is -10, plus 1 is -9, x squared. Minus 3x minus 4. Oh, no, I'm missing something. There's an 8 here, 8 and 3, so it's an 11x, not 3x, because I forgot this 8. 11x minus 4. And then multiply by x. So we got x to the 5th minus x to the 4th minus 9x cubed minus 11x squared minus 4x, and that equals 0. So that's our polynomial. So far, so good? It's a lot of work, but that's what you end up with. You have to be very careful. I mean, I overlooked that 8. So -8, -3 makes it a -11.
Right.
Basically, we're just working backwards what we used to do. Used to I give you this, we'd factor backwards. Now I give you the answer, you give me the question. Okay, this next topic is zeros of polynomial functions with real coefficients. That example. And that's the stuff we've been doing all along. Like x squared plus 3x plus 3 equals 0. How do we find the zeros there? It's what kind of equation is this? Is it linear? Is it quadratic? Is it cubic? Is it?
It's quadratic.
It's quadratic. So what do we know? What methods do we know to solve quadratic equations? Can we factor it? Okay, let's check it out. If we can factor it. What goes in the first spaces?
X. That's the first thing that goes in each parentheses.
What signs go in there?
Positives.
So they're both the same. They're both positive.
Yep.
So what times what equals 3? When you add them, you get 3. Okay. So there goes the factoring. We can't factor it. So do we know any other method to solve this? Factor if possible. So if you can't factor, we use the quadratic formula. Which is x equals negative b plus or minus b squared minus 4ac over 2a. So we have to label a, b, and c first. What is a?
A is, x squared, B is.
A is 1.
Is 1,
These
it's 3.
a, b, and c are numbers. You cannot have, in this part, you have no more letters. The only letter is out here. So now we plug them in there. Negative b, b is 3, plus or minus 3 squared, 4 times a times c, 4 times 1 times 3, over 2 times 1. Three squared is 9. 4 times 1 times 3 is 12. Negative 3 plus or minus 9 minus 12 is negative 3 over 2. Because we cannot have negatives inside the square roots, it becomes an imaginary number. So those are my x-intercepts. We have two of them. We have negative 3 plus I radical 3 over 2 and negative 3 minus I radical 3 over 2. So let's look at, so we know our answers can be imaginary, but it's important. These are complex conjugates. The sign between there has changed. All right. Find the polynomial of degree 6 with the zeros negative 2 plus 5i, negative 2i, 1 minus radical 3. We're supposed to have 6 solutions. What's missing? Well, we have x equals -2 plus 5i. That's this one. There should be its conjugate, which is -2 minus 5i. Another one is x equals -2i. Its conjugate is x equals positive 2i. And the last one, x equals 1 minus radical 3. Its conjugate is 1 plus radical 3. Those are our 6 solutions. So these are the given zeros. And this is what you found. Don't worry about it. We don't have to multiply these out. Because what would be the next step for you? We have to make them equal 0. So this one would be x plus 2 minus 5i equals 0. X plus 2 plus 5i equals 0. That's the second equation. X plus 2i equals 0. X minus 2i equals 0. X minus 1 plus radical 3 equals 0. X minus 1 minus radical 3 equals 0. So these are the pieces that we'd multiply together. It would be x plus 2 minus 5i times x plus 2 plus 5i, x plus 2i, x minus 2i, x minus 1 plus radical 3, x minus 1 minus radical 3. Now, I'm not going to make you all multiply those out. What would happen in this one, it'd become very big, and then all of a sudden everything cancels out. All the x squares cancel out. All the radicals disappear. So it'll become very small, but that's where you go from here. All this question really asks for is, here's the 3 zeros. I want 6. Find me the last 3 that are missing. The complex conjugates. Another example. Find the polynomial function of lowest degree with rational coefficients that has negative radical 3 and 1 plus I as 2 of its zeros. What do we have? Find the polynomial of lowest degree with rational coefficients that has negative radical 3 and 1 plus I as two of its zeros. So with this, what will our degree of our polynomial be? It's asking the polynomial of lowest degree. What's the lowest degree we can have?
The lowest we have is one.
No. Because we have two of the zeros already. So maybe that's two answers there. No. Because our zeros are negative radical 3. And then 1 plus I. Yes. We have to have the conjugate pairs of these. So we have to have x equals radical 3 and x equals 1 minus I. So we have to find the conjugate pairs of those, and now we have to multiply them together to get the polynomial. This question wants us to go all the way out because it's asking for the polynomial itself. So we got to set them equal to 0. So x plus radical 3 equals 0. X minus radical 3 equals 0. X minus 1 minus I equals 0. X minus 1 plus I equals 0. So our polynomial will simply be all of these multiplied together. And we can see automatically from here, since we have x times x times x times x, it's going to be a degree 4 polynomial or a fourth order polynomial. So let's multiply these together and multiply these together. X times x is x squared. X times negative radical 3 is negative x radical 3. Positive x radical 3. Positive times negative is negative. Radical 3 is simply 3. Well, because it's square root of 3 squared. And the second pair, x times x is x squared. Positive times negative is negative. X times 1 is x. Positive is a positive. Xi. Negative 1 times x is negative x. Negative is a positive 1. Negative I. Negative xi. Positive I. Negative I squared. Instead of bobbleheading, do you see what I'm doing here? So in other words, if I took this page off the screen, you can still do it. That's the important part. Don't just copy what I'm doing because that means nothing to you. All I'm doing here is multiplying every term in the first parenthesis to every term in the second parenthesis. Every term in the first, every term in the second. Now I combine like terms. In the first bracket, these two cancel. So we have x squared. Square root of 3 squared, those cancel, so it's x minus 3. X squared. negative x, negative x is negative 2x. Positive xi, negative xi cancel. Negative I, positive I cancel. I squared becomes negative 1, so it changes that. So it makes it positive 1. So you have positive 1, makes it a positive 2. That's the hardest part. And that's why you can't be chintzy with your space of your paper, because the more space you have it, the bigger your numbers are, the more you can see it. If you condense it, you'll get lost really quick. Now I got to multiply everything in the first times everything to the second. X squared times x squared is x to the fourth. Positive times negative is negative. X squared times negative 2x is negative 2x cubed. Positive times positive is positive 2x squared. Negative times positive is negative. 3 times x squared is 3x squared. Negative, negative is a positive. 3 times 2 is 6x. Negative, positive is negative. 3 times 2 is 6. Combine like terms. It's always the same process. We have x to the fourth. We have negative 2x cubed. Or, yeah, negative 2x cubed. So positive 2x squared minus 3x squared is negative 1x squared. Plus 6 minus 6. And there's our polynomial. Does that make sense so far? It's a lot of writing. I apologize. But now here's where we start putting everything together. Now we can start solving for, we can find the intercepts of much larger polynomials. We first have to talk about the rational zero theorem. So let P of x equal the polynomial a sub n x sub n a n minus 1 x to the power n minus 1 plus dot 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 a1 x1 plus a0. That's how we always write polynomials. Consider the rational number denoted by P over Q. where P and Q are relatively prime numbers. Relatively prime numbers, it can have positive or negative one as a factor. So you can have positive and negatives. So relatively prime numbers are numbers that have -1 and 1 as factors. No other number other than those two. So if P over Q is a 0 of our polynomial, then P is a factor of A sub 0 and Q is a factor of A sub n. That's the theorem. Here's what it means. If we can find some rational number that's a 0 of our polynomial, that means these values have to come from both the beginning and the end number. P are the factors of your constant, and Q are the factors of your leading coefficient. Remember I said earlier, the leading coefficient and the last term are the most important part. Everything else in the middle is just there. It helps us define where the rest of the graph is. So what we have to do is no matter what polynomial we're given, we have to find the factors of the first and last term. Let's look at this example. Example 5. F of x is equal to 3x to the 4th minus 11x cubed plus 10x minus 4. Find the zeros of that. The question is, given this, find the rational zeros. And factor f of x into linear factors. So find the rational zeros. And then once you find the rational zeros, then we have to determine which ones are the actual zeros and put them into linear factors of the function. Before we go into this one, let's do a simple one. Because what are rational zeros? We just defined that. Rational zeros, the P over Q. And once we find the appropriate P over Qs, those are x equals those numbers. And we can find the zeros of this. those factors. Let's start with something easy. If our function is x squared plus let's see here. So first, let's find what the rational zeros. Which are the P over Q. What does P represent? P represents the factors of your constant. Q represents the factors of your leading coefficient. So the factors of your constant, factors of A2, your leading coefficient, factors of leading coefficient. So in our case, what is P? What number do we look at for P?
6.
6, the constant. And Q is what? 1. It's the leading coefficient. So what we have to do here is we have to find the factors. What are the factors of 6? What times what equals 6? 1 times 6 or
3 times 2.
1, 2, 3, and 6. So 1 times 6 or 2 times 3. Those are factors. What are factors of 1? Is just 1. So those are the factors of, put your phone away. You don't need that. Now, do we know if they're positive or negative? Not yet, we don't. There's something we'll do later on that's going to tell us if they're positive or negative. So with these, we have to look at positive and negatives of each of them. So the rational zeros are the fractions. We have 4 on top and 1 on the bottom. That's 4 possibilities, and they can be positive or negative. So the first one can be positive 1 over 1. Or it could be negative 1 over 1. Then it could be positive 2 over 1 or negative 2 over 1. Positive 3 over 1, negative 3 over 1. And then 6 over 1, negative 6 over 1. So our rational zeros, they can be positive or negative 1, positive or negative 2, positive or negative 3, positive or negative 6. Those are my possible, the rational zeros. So far, so good. What have we just done? I gave you an equation here. How many answers, how many numbers can you put in place of X to see if they're right or wrong? Infinite. You can put negative any numbers and positive any numbers. So we have infinite number of possibilities here to make this equal 0. What this just did, it went from infinity to 2, 4, went down to 8 possibilities. We've narrowed it down. How do we check these?
By plugging them in lieu of X.
You could plug that, but that's the harder way. And because last time, remember, I gave you an equation. Remember that one said P of 10? We could plug it in the equation, or we can use something else. We can use synthetic division by synthetic division. So all we have to do is go through these 8 possibilities until we find how many answers do we need? Until we find our 2 answers. So let's start with positive 1. We have 1, 5, and 6. Bring down the first term. 1 times 1 is 1. 5 plus 1 is 6. So that one doesn't work because it's not 0. We try negative 1 now. 1, 5, 6. Bring down the first term. 1 times negative 1. 5 minus 1 is 4. Negative 1 times 4 is negative 4. That still doesn't work. So 1 is not a solution. Or negative 1. So we try 2 and negative 2. Two times 1 is 2. 5 plus 2 is 7. 2 times 7 is 14. That doesn't work. So we'll try negative 2. Negative 2 times 1 is negative 2. 5 minus 2 is 3. Negative 2 times 3 is negative 6. So negative 2 is a 0. So X equals negative 2 is a solution, which means X plus 2 equals 0. That means X plus 2 is a factor of our polynomial. Remember, zeros, intercepts, factors, they're all the same thing. Remember, we need 2 answers. X plus 2 is one of them. Well, here's the second one right here. Since it's 0, this is my constant and this is my X. So it's X plus 3. That's the second factor. So the factors of our polynomial, x squared plus 5x plus 6, are x plus 2, x plus 3. And that's what part B says. Put your function into linear functions, or linear factors. So that's what we're going to use this for. So let's go back to our initial question. Let's work this one out. Back to example 5. Three x to the fourth minus 11x cubed plus 10x minus 4. Did I go wrong? Yeah. So first off, we have to do the rational zeros, P over Q. What is P? Factors of which one? The constant. So it's the factors of 4. Don't worry about the signs because remember, we got to take the plus or minus of them anyway. And the Q is 3. So what are the factors of 4?
1, 2, and
1, 2, and 4. What are the factors of 3? So by looking at this, we've just narrowed down from infinity to 6 possible answers, or 12 possible answers. Because there's 2 times 3 is 6. And then we got to look at the plus or minus of each one of them. So it's going to be plus or minus 1 over 1, plus or minus 2 over 1, plus or minus 4 over 1, plus or minus 1 over 3, plus or minus 2 over 3, and plus or minus 4 over 3. There's 1, 2, 3, 4, 5, 6. That's the 3 times 2 part. And there's plus or minus. So there's 12 possible answers we have to look for. But all we have to do is find 4 of them. But using synthetic division, once we find the third one, then we have the answer. So we have it's not that much work from here on out. So what we have to check, 1 divided by 1, 2 divided by 1, 4 divided by 1. These are our inputs that we have to try. Those are our rational zeros. So once we have these, now we got to use the synthetic division. Let's try 1 and -1. So with 1, remember our function is this. The highest exponent is x to the fourth, x to the third, x squared, x, and the constant. So it's going to be 3, -11, 0, 10, and -4. You see the importance of why I always label the top of the numbers, the columns, because this one doesn't have x squared. I got to put a 0 there. So bringing the first one down, 1 times 3 is 3. -11 plus 3, so it's going to be -11 minus 3 is 8. 1 times -8 is -8. 0 plus -8 is -8. 1 times -8. 10 minus 8 is 2. 1 times 2 is 2. -4 plus 2. So 1 is not a correct answer. So now we gotta try -1. Yes. Yeah, that's what we talked about. Whenever you use synthetic division, it's only a 0 if it equals 0 at the very last number. Bring the first number down. Repeat the process. -1 times 3 is -3. -11, -3 is -14. -14 times -1 is +14. Add those together. -1 times 14 is -14. 10 minus 14 is -4. -1 times -4 is +4, 0. So x equals -1 is one of our factors, or zeros. So now all we have to do is look at this equation right here. To be safe, since x and -1 was a factor of this one, I have to only look at this equation now. -3, -14, 14, -4. Try with -1 again. Whatever this one is, try it again. It could have a multiplicity. Remember, multiplicity is when you have multiple of the same answers. So -1 could also have 2 or 3 or 4. All of them could be -1. So we have to check it. -1 times 3 is -3. 14, -14, -3, -17. Makes it 17. 31, -31. So we only have one answer of -1. Okay, so that took care of the 1 and -1. Now I gotta try 2, -2, then 4, -4. I keep on going. Try 2 and -2. But remember, you don't have to go back to the original equation. Since we have a 0, this is the equation we have to look at now. 3, -14, 14, -4. Let's see what we have here. Finish today. So 2 times 3 is 6. 14 minus 6 is 8. 14 is bigger, so it's -8. 2 times -8 is -16. 4, so it's -2. 2 times -2 is -4. Makes it -8. So 2 is not it. Let's try -2. Bring down the 3. So -2 times 3 is -6. -14, -6 is -20. -2 times -20 is +40. Now it's going the wrong direction. So -2 is not right. Let's try 4 and -4. 3, -14, 14, -4. Four times 3 is 12. -14 plus 12 is -2. 4 times -2 is -8. 14 minus 8 is 6. 4 times 6 is 24. So it's not 4. Does everybody see what I'm doing right here? Yeah, so now, because I'm gonna, well, I'm gonna work with each one of these until we get it, because you have to see how it's done. Let's try -4. -14 times 3 is -12. Makes it -26. Ooh, that's going the wrong direction already. So -4 is not going to work. So let's try, now we're done with 1, 2, and 4. Let's do the fractions now. 1/3. 1/3. And then -1/3. 3, 14, -14. 3, -14. 14 and -4. 3, -14, 14. Negative 1/3 times 3 is 1. This is where you have to practice your division, multiplication of division problems. It was 1/3 times 3, the 3's cancel, you have 1. -14 plus 1 is -13. -13 times 1/3 is -13/3. To combine these two, we have to have a common denominator. So it's 3's common numbers. 14 times 3 is 42/3. 42/3 minus 13 is 39. 29/3. It's just going wrong direction. So that's not going to work. -1/3 times 3 is -1. -14 minus 1 is -15. Ooh, this one might look good too. So -1/3 times -15 is a +5. 15 divided by 3. So 14 plus 5 is 19. No, that's not going to work, because 1/3 times 19 is not going to give you 4. So the next one, let's try 2/3. 3, -14, 14, -4. The fractions are going to take you the most time. Two-thirds times 3 is equal to 2. The 3's cancel. -14 plus 2 is -12. 12 divided by 3 is 4. 4 times 2 is, so it's -8. I'll show you. It's 2/3 times -12. The 3 goes into 12. The 4 times 2 times 4 is 8, so it's negative 8. 14 minus 8 is 6. 2/3 times 6. So we have 2/3 times 6. 3 goes into 6 2 times. 2 times 2 is 4. So x equals 2/3 is another 0. Now, if you look at this equation that we have to deal with now, it's a quadratic equation. This one is 3x squared minus 12x plus 6. The reason I say it's important is because now we know how to solve quadratic equations. We can use the quadratic formula or we can factor it. The first thing you want to do, is there anything in common with all of these? Yes, they all have a factor of 3. If I divide each one of these by 3, each term by 3, x squared minus 4x plus 2 equals 0. How do we solve that one? It doesn't factor. What times what is 2 when you add them, you get 4? So we have to use the quadratic formula. Pretty much that'll be your go-to, so you don't have to worry about factoring. Negative b plus or minus b squared minus 4ac over 2a. So it's negative of a negative 4 plus or minus negative 4 squared. 4 times 1 times 2 over 2 times 1. Negative, so it's 4 plus or minus 16 minus 8 over 2. 4 plus or minus 16 minus 8 is 8. Square root of 8 can be simplified. 8 is made up of 2 times 2 times 2. Since there's a pair of 2's inside there, I can take it out. Again, that's the stuff we did in chapter 1. Now, on top, they both have a factor of 2. Four is made up of 2 times 2, and 2 is 2 times 1. I factor out 2. The 2's cancel, so my last two answers my last two x-intercepts are those. Yeah, that's how we have to first simplify inside the radical. Square root of 8 is 2 times 2 times 2. There's a pair of 2's, so it comes out in front. 4 and 2 both have a factor of 2. I can take out 2, so 2 times 2 is 4. 2 times that is that. The 2's cancel. So my solutions so far are x equals -1, x equals 2/3, x equals 2 plus radical 2, and x equals 2 minus radical 2. Those are my zeros. Why is it important that I have 4 of them? Because the equation itself,
That's a degree of
it's a
4.
degree of 4. So I have to 4. Now, the second part of the question, those are my zeros. Those are my x-intercepts. It says factor into linear factors. In other words, I want it to be equations, x plus something. You can sort of make these equal to 0. So it's x plus 1 is equal to 0. In this one here, yeah, you could make it x minus 2/3 equals 0. X minus 2 minus radical 2 equals 0. X minus 2 plus radical 2 equals 0. So my polynomial is made up of x plus 1, x minus 2/3, x minus 2 minus radical 2, x minus 2 plus radical 2. So far, so good. There's one thing missing. Remember in this step here, when I divided by 3, that 3 has to go in front of the whole thing. Because it's part of my answer. So there's my polynomial. I'll finish up next time because we have what I want to do one more example. And then remember, when we first give you the equation, there's an infinite number of possibilities. We narrow it down using the rational zeros. We can go even further by, I can tell you the number of positive answers, the number of negative answers, and the number of complex answers. We'll talk about that next time. Because, for example, if it's said that notice here, I have a negative, positive, and these two are relatively positive because the 2 is positive. So notice we only have one negative answer here. If I would have known that earlier, I didn't have to check. Once we found -1 as an answer, I wouldn't have to check any of the negatives anymore. I'm done. All I do is now I took those negative possibilities, threw them away. Just look at the positive ones. And that's what we're gonna look at. Because every time we get closer and closer and closer to just narrow it down as fast as we can. Yeah, I mean, we could push through it, but it'll take another 30, 40 minutes to finish everything else. So I'll do it next time. So definitely start practicing these problems.